Hello everyone, and welcome back to another video lesson. We're beginning week 2 of remote learning, and this is our third lesson. Today we're going to be talking about arc length and sector area. Before we get too far into the lesson, I want to go over a couple of vocabulary terms real quick. So when you're looking at this picture in the Explore section, I'm going to outline this shaded region with this blue here a second. This shaded region of the circle that I just outlined, that is what we call a circle sector. So I'm just going to write here, this is called the circle sector or a circle sector. And that is primarily what we will be finding the area of today. And then I'm going to draw I'm going to trace rather, this part of the circle that goes from A to B. That piece is part of the circumference of a circle. That is what we call the arc. So when it says arc length, section 3 arc length, we're talking about the partial circumference of a circle, the distance from A to B in the picture. And sector area is referring to the partial area of a whole circle. So in this box, it says explore how much of the circle below is shaded. Well, we're really looking at the circle sector. They want to know how much of this circle does the circle sector take. When I'm looking at this, I see that the circle sector has 90 degrees written right there. So I know that it is taking 90 degrees out of the total 360 degrees in the shape. So I'll write that down here a second. So I have 90 degrees. Oh, didn't take it. We'll try that again. We have 90 degrees out of our total 360 from the circle, which is equal to 1/4 or 25%. So 25% of the circle is shaded. 1/4 would be the reduced fraction. Just a heads up, most of the time in this unit, we will be not simplifying our fraction and we'll be sticking with that 90 degrees over 360. Then it says, how could we find the area of only the shaded region? Well, we can find the area of only the shaded region if we find the total area of the circle and multiply it by the fraction of the partial area. So you have the circle area times the fraction, which I'm going to write like this, of the partial area or of the circle sector. So actually we'll just go ahead and we'll write times fraction of circle sector. So what if I wanted to know about the arc length? How would I find the length of my arc? Well, it's the same type of thing where I would take, but instead of area, the circumference. So it's the circle circumference times the fraction of the arc, which will be the same fraction that was used in the area. So if we were to write a general formula for that, first thing we want to do, I briefly drew this and I took it off because I want to explain that Greek letter real quick. In order to fully recognize what these formulas are saying, you have to remember that we have this Greek letter called theta. It looks like this. It's like a 0 with a line through the middle. That theta is what we're going to use to represent the number of degrees in our circle sector. So we have theta is equal to the given measure of the circle sector. And we'll need to know that for both of our formulas. All right, so let's go ahead and start with the formula for the circle sector itself. So if we're trying to find the sector area, the general formula is equal to the area of a circle, which is pi times r squared. That's what we talked about last week. Pi times r squared multiplied by the fraction of the circle sector, which in general says times, we'll zoom in here a second, theta over 360 degrees. So that's the general formula for sector area. Again, that theta is the number of degrees of the circle sector. All right, now let's go ahead and switch to the formula for arc length. So if I'm trying to find arc length, in general, the formula is the formula for circumference of a circle, which is 2 times pi times the radius times the fraction of the partial circle again. So that is going to be, again, that same fraction of theta over 360 degrees. So we're strictly working with the degrees inside the shaded region. All right, so now that we have our general formula, we're going to go ahead and get started on some examples. All right, here we are in example number 1. It says, find the area and arc length of the shaded region below. So I have this circle given to me, and when I'm looking at the shaded region, I notice that it has 131 degrees marked as the degrees of the circle sector, and I have my given radius of 12 meters. So now I'm going to take those pieces of information, I'm going to use them to find both the sector area and the arc length. I'm going to go ahead and start with area. So if I remember from the formula that I created above, I have area is equal to pi times the radius squared times the total number of degrees out of 360. So I have, in this example, I have pi times 12 as my radius, so I have 12 squared, times I have 131 degrees out of 360 degrees. All right, so if we break that down, that really means that I have pi times 12 squared, which is equal to 144, times, and I'm going to just keep my fraction of 131 over 360. Now I'm going to go ahead and I'm going to simplify my fraction and the 144 all in one step. So when I do 144 times 131 divided by 360, that simplifies down to 52.4 times pi. 52.4 times pi. If you remember from before, if you're leaving your answer in pi form, this is where we would be done. In general, we want to use decimals, and we're going to use 2 decimal points. So we're going to go ahead and multiply that out. 52.4 times pi is equal to 164.62 approximately. So I'm going to say that area of my shaded region below, or my area of my shaded region, is equal to, about equal to, area is about equal to 164.62 meters. All right, so now that I have my area, I want to go ahead and find my arc length. So my arc length formula from above, and I'm just going to say arc length is equal to 2 times pi times the radius times my fraction, which in general was theta over 360 degrees. So in this example, I have 2 times pi times my radius, which was 12, times that same fraction of 131 degrees over 360 degrees. I'm going to go ahead and simplify 2 times 12 times 131 over 360 all in one step. You can actually type that right in your calculator, all in one step. Just make sure that you are putting parentheses around your 131 divided by 360. Just to be careful, for some of your calculators, it might make a difference. So when I put all that in my calculator and multiply it out, it gives me that I have 8.73, where the 3 is repeating, times pi. When I multiply those two irrational numbers together, that gives me, for my arc length, the total of about 27.44 meters. Again, rounding to 2 decimal points. All right, so that is the process for finding area and arc length of the shaded region. The next two examples are pretty similar, but this is in general all you need to know. So that is where we are going to stop, but I will provide example 2 and example 3 and another video that you can choose to watch if you would like to see what the rest of these look like as well.